Today we talk about the very important things in calculus. It's chain rule. First we need to know two things. First is y equal f u. And a u equal g x. First example, if I give x an increment delta x, then I will get just g x. Then I'll get u plus delta u. This. Then now we draw two decal x's. This is x. This is u. This is u. And this is this. First, let's say it have a function, and this is another function. If I take this function, first, if I give a delta x, now we have a delta x increment. Then if, of course, you can find a average slope. Maybe it's in here. You can find an average slope. Then if you find an average slope, then you let the delta x times the average slope, then you will get a delta u. You got delta u. And if I put the delta u, I let the u-axis rotate to the horizontal line. So here's a delta. Then the same, if I got here average slope, then I let the delta u times the average slope, then I will get a delta y. Like this, I will get a delta y. So now, this one I can write delta u. Because we said this, now we can write it. Slope is just have a dash. So it's gx dash times the x. So then I can, and here is, because first it's this one, then you will get a delta u. That means a delta u. Then if you time this average slope is f u dash. So it's just g x dash times delta x times f u dash equal delta y. It's this. Now I write this. But now we have a problem. What? Sometimes if you have a function, it's hard to find the average slope. Example, if the function is x squared, so in every time the slope is not same, so it's hard to find the average slope. So we have an idea. If you shrink the delta x to dx, that means it's less than n epsilon radius. That means we can't see it. So if I let the dx times the slope, and I will get a du, and I put the du here, and if I du times the slope, and I will get a dy, That means we have a very gentle or smooth curve. Now we can write the limit. Delta x approaching 0. It's delta y over delta x equals g x dash times f u dash. So now it's equal, it was x dash times f u dash, like this. If you really know what we are talking about, we can change gx dash to du over dx, and fu dash is dy over du. So we can write dy over dx equal du over dx times dy over du. So this is the chain rule. Now we see the first example. Example is d over dx sine x. This problem. First we see this one because if I put the square out, it's the same. So I just write dx and this. And here we stop. First you see, if I have the dx increment and I will got a d sine x increment, that means in here we have a du increment. Now put the sine x increment here, then we will got a d sine x square increment. Now we know this. Now first we have the dx increment, then times this point's slope, then we will got a du increment. Then we put the du rotate to here, and then we let the du times this point's slope, then we'll got a dy increment. The problem is, what is the two slope? The first slope is we plug the x value into the derivative of the sine of x. Then you will know. Then you will know the slope. We proved it before. It's cosine of x. The next slope is I plot the x value in this function, then I will get a sine of x value, then I put sine of x value here, and I will plug the sine of x value into the derivative of the sine of x square. And this is a power rule. So it's 2 sine x. And this one is sine 2x. Why this one is equal to this, we will prove it later. Actually, if you want to know what is the dy, you just let the dx to time the two slopes project. Now we see the second example. The function is y equals this one, and we know his slope, so of course it's dy over dx equal d over dx. D over dx is sine x squared plus y squared. This equal. What's this? Regardless of what's inside, and you have an increment d this one, and you will got an increment d sine this one, so you got a last slope equal cosine x squared. Now we see what is inside. First, of course, first is inside this one. You have a dx increment. Then you will get this one increment, right? But of course we need to derivative this one. And derivative this one is derivative x squared and derivative y squared, right? X squared is very easy, just 2x. And plus, what's y squared? Inside the y, there's another function. And when you have a dx increment, then you got a dy increment. Of course, the slope of the y is a dy over dx. And the other one is, if you have an x value and plug it in the y function, then we'll get a y value. And I plug the y value into the derivative of the y square. Then you will got the next value, the last value. The last slope. So it's 2y, and times, so it's dy for dx. Sorry, the 2y is the second slope. Then someone will ask, dy over dx, and this is dy over dx. Regardless, because inside of it have the same rule. D So this is the farmer's answer.